Hello, my name is Mark Kelly. Welcome to the AI Ireland webinar. We are talking about AI in travel, and I'm very happy to welcome. We've got Mike Wilson, Head of Data Science at CarTrawler, and we also have Chris Laffey, Senior Data Scientist at CarTrawler. And today we will be discussing some of the advances in machine learning to give a better service to customers when we're actually on travel and actually look at some of the innovations that how they come about, some of the challenges to put them into production, and really just kind of a walkthrough of what it was like actually on this journey. This could be pretty interesting for anybody who wants to either end this journey or starting it, or actually maybe had some bumps on the road, because we'll be able to go through some of those in a little bit more detail. And also, what's really exciting about this is it is at scale. I'd like to introduce Mike Wilson. Mike, I'm going to pass over to you to start the presentation, and I'm now going to jump off my camera.
Um, okay, thanks, Mark. As Mark said, I'm Mike Wilson. I'm Head of Data Science at CarTrawler, and I'm here today with Christopher Laffey to bring you through our journey to productionizing ML at scale at CarTrawler. So firstly, I just want to bring you through sort of who CarTrawler are and what we do, as many of you may not have heard of us. Um, CarTrawler connects partners, customers, and suppliers through our global online travel marketplace. We're the leading B2B technology provider of car rental and mobility solutions, servicing over 70 airlines and 500 travel partners around the world. You can see a selection of our partners and suppliers on screen. And our proposition delivers unparalleled performance for the biggest brands in travel by combining leading technology with revenue management and data science capabilities. We're focused, our B2B focused, and provide experience and expertise to the market in this area. We're the market leader in traffic monetization and are proud of our bespoke revenue management platform underpinned by data science, which we'll talk to you about today. We operate cross-functional trading squads to drive improved performance across the business. We've comprehensive breadth of supply across the world with over 55,000 locations. We have custom-built market-leading tech that is highly scalable, and all of this combines to create a best-in-class online retail experience for our partners and customers. The data science team, which we're talking about today, play a significant role within the organization now, not only through developing high-performing machine learning solutions, but also by providing expertise in product design and technology advancements. We're a team of highly skilled and experienced data scientists and engineers responsible for driving profitability optimizations through automated data-driven solutions. The team currently is divided into two sub-teams, one focused on building machine learning algorithms to automate processes such as pricing, recommended sorting, and forecasting, while the others, the ML Ops team, is focused on developing, deploying, and maintaining the tools and services we've built. As for the global car rental market, the COVID pandemic hit the car rental industry hard, as it did to many other industries, with revenues plummeting. I think in 2020, we were down to 5–10% of bookings and revenues at certain stages of the year, but has rebounded strongly this year in particular, with revenues expected to reach 2019 levels later this year. A perfect storm of reduced car manufacturing and supply, driven by chip shortages and suppliers defleeting during the pandemic, has resulted in significant increases to car rental prices in the market at the minute. Prices have more than doubled compared to 2019 in some cases. While this is a good tailwind for us, it's not great for the end consumer. And we have sort of concerns around conversion and how that's going to look in the future. One piece of advice: if you're planning a summer holiday and you need to book a car, I'd advise to book sooner rather than later. So that's kind of CarTrawler and who we are and what we do. But as I said, today we're here to talk to you about our journey to a high-performing and high-impacting data science team. So firstly, just to set the context, I want to give you a quick history lesson. The data science team in CarTrawler was created around sort of 2014, 2015 time as a relatively small business unit. Our day-to-day work comprised of running ad hoc analysis into specific elements of business performance. managing the quality of data and creating new views on top of existing data sources, supporting the business with data requirements for new products or designs, and in some cases, defining the inputs for business rule-based applications, such as our then approach to recommended sorting. We also worked with some third-party providers in terms of data science tools. It remained that way until approximately 2017, 2018, when we started to explore building out our own in-house tech capabilities to really take advantage of the power of data science and AI. We had an ambition to move away from sort of small scale based analysis to more automated, large scale production models. Looking back to then compared with now is night and day. We've significantly grown our capabilities from a tech point of view and in terms of how we impact business performance. Just a flavor, we now have over 15 machine learning models live in production being scored real time. We have a scalable and flexible multivariate testing infrastructure, allowing us to run multiple tests on a daily basis. And we've sophisticated ML pipelining tools. All of these tools and services have been built in-house with in-house expertise. And all of this with a relatively small team, so we're quite proud of that achievement. But how did we actually get there? So I think firstly, to understand how we got there, it's important to sort of highlight the bottlenecks and challenges we faced and that were holding us back at the time. Here, I present to you 4 key issues and challenges that we had. And sort of over the next few years, we set out to overcome these, and we'll outline how we did that in the coming slides. The first one is we had no robust testing infrastructure. As many of you will know, testing is key to understanding and verifying the impacts of new products or upgrades. At the time, we did run tests in the past, but in a very ad hoc manner with little to no control or flexibility over how they were executed. Each test was run in a different manner each time, which leads to a lot of issues, a lot of problems. It just wasn't a scalable approach. Secondly, we were heavily reliant on other functions to support in the development of data science solutions, be that sourcing of data, running tests, developing applications. This just made every single project or every piece of work that we worked on that little bit slower, as we had to go through prioritization with other teams and rely on resources supporting us. Thirdly, around the business, there was somewhat of a fear of the machine taking over and people losing control over important revenue management operations, such as pricing and sorting in particular. These traditionally had been very manual processes controlled by many different people across the business. So people like to have that control, but it was a very manual process. There was no testing, there was no validation. So there was that fear of people losing that control and machine or data science taking over. And lastly, and sort of most importantly for us, we had no ability to run machine learning models real time, which we felt severely hampered our ability to get the most out of machine learning and data science practices for the business. To give you an example, back in 2017, we attempted to build a machine learning model for sorting our content on site. This was our first attempt at machine learning to sort of really impact the business. The project in total took about 1 year, with about half of that time spent just recoding the final model into Java to be used on our production server. This was just a painfully slow process with a lot of back and forth between us and our P&T teams. And then once we finally got the model live, we had no control over it. We needed to prioritize updates or upgrades with other competing priorities around the business. We just felt like this just couldn't continue or really work long term, and we weren't delivering the uplifts and the benefits that we really wanted to deliver. So that's kind of just an overview of the challenges we faced at the time and sort of things that we wanted to improve over time. Now, I'm going to hand you over to Chris, who will take you through the steps we took to improve our capabilities and overcome these challenges.
Thanks, Mike. So for the next few slides, I'm going to take you through how we scaled our data science and machine learning operation, and how we did that through really iteratively adding new pieces of functionality to our tool set. And I think it's important to note here that the keyword is iteratively. It wasn't one big bang. It involved us figuring out what we needed next as we progressed as a team. So before we go on to examine the evolution of our machine learning pipeline, that being how we take raw data and use it to employ revenue generating decisions, I'd like to call out three key design principles that really shape the tools and technologies that we built. The first being traceability. So we needed to ensure that we could trace back all our revenue generating decisions. So for example, pricing and sorting, to the data that led to those decisions in the first place. Second being reproducibility. We really needed to be able to recreate as close as possible the exact same output or model by following the same steps. And this is to ensure consistency both across time and across developer. And thirdly, and one of the most important ones, is developer user experience. So improving the developer, or in our case, data scientist user experience, is really crucial to reducing the time to market and getting those ideas from the ideation stage into production as quickly and as efficiently as possible. And I hope it's evident how these three principles do come into play as I go through the different tools and services over the next few slides. So as a starting point, and as Mike alluded to in the first few slides, pre-2018, we had a very basic operation in terms of data science capabilities. Our pipeline, if you want to call it that, consisted of us ingesting data, running ad hoc analysis, making manual changes. So for example, manually changing our pricing in the back-end code, and then off the back of that, aiming to generate revenue. This approach was really subpar and it was unreliable. So with that, in 2018, we invested significantly in our MVT, or multivariate testing capabilities, to allow us to run tests in a traceable and scalable fashion, as opposed to the very manual approach previously taken. And the MVT capabilities that were introduced consisted of two main parts. Firstly, a platform to create and run our MVT tests, and secondly, a platform to report on those tests. With our testing platform, we gained the ability to run a large number of A/B, or ABCDE, tests in parallel through segmenting our traffic. We also gained the ability to specify each side of the test. So for example, what price or what sort order side A sees versus what side B sees. And we are able to now do this in a consistent and programmatic manner. And this capability extends to more than 30 different platforms. So we've mentioned before, recommended sort order, pricing, but we also run tests on our front-end displays, our claims, and a whole host of other things. And naturally, what followed the introduction of the testing platform was the ability to report on all of those tests at scale. So we developed an automated and scalable MVT reporting platform, which allows us to run complex analysis on all the tests, and then output those results to the stakeholders in a consistent manner that they're able to easily digest. And I suppose to sum it all up, some of the benefits with this platform, we've now gained the ability to run hundreds of A/B tests across multiple different segments of traffic. And these segments can be split across things like source and destination, touch points, pickup dates, a lot of other things. We're able to tell exactly what side of the test a customer has seen and tell whether that has resulted in a booking. And then through our reporting platform, we're then able to derive the idea behind the test, whether or not it has actually led to an increase in revenue or not, and whether the hypothesis has been a success. So just a few screenshots here. we see an example above of some of the configuration files that allowed us to set up and define the test within our MVT platform. And below is an example of how we report on our A/B tests. And all of these MVT capabilities and the platform itself served us well for quite some time, allowing us to test and build and discover new things. But as we began to adopt machine learning more commonly throughout the team and throughout the business, the platform really began to show its limitations. After some time, having had our MVT platform for a while, we naturally tried to push the boundaries of how granular and bespoke we could make our tests. But in doing so, this caused a number of issues. Firstly, complexity. The MVT configuration files became too large and too difficult to maintain. Development, trying to make changes to the existing platform required dev time from our engineering department, which could mean weeks, if not months, and then trade-offs. So the difference between the optimum model that we can envisage and what we could actually squeeze into the existing setup became too large. And like in essence, we were basically trying to fit a square shape into a round hole, and we couldn't apply machine learning through our existing MVT testing platform. So with that, the next step in our machine learning pipeline came in early 2020. We developed and launched our machine learning model serving platform, which really enabled decisions that were made throughout our e-commerce sites to leverage the power of machine learning. So what this did and what this machine learning serving platform did was it allows us to strip out the middleman, which consisted of generating and uploading these MVT config files, and instead deploy the model which generated those files in the first place directly into production. And this itself greatly reduced the time to market of new ideas and allowed us to actually leverage machine learning as part of our booking funnel. I suppose then the next thing that followed our machine learning serving platform was the monitoring and logging of the service. And one key factor here was the latency of model predictions. So we really needed to be sure as a business that we can make intelligent decisions without ruining the user experience through increasing the latency in the booking funnel. And here we just have some quick screenshots of some Cabana dashboards on our serving platform, at the top detailing the number of calls to each of the individual services, and the bottom showing some info on the response time for those requests in milliseconds. And then following unlocking the ability to serve our models, later on in 2020, we really doubled down on improving the processes and the pipelines to generate these models in the first place. So leveraging the cloud, we built our model training pipelines to enable the data scientists to build their models in a consistent and scalable fashion. And following building out our model training pipelines, and coupled with having the ability to serve our models, throughout 2020 and 2021, we really focused on improving model testing and validation. And this was achieved through incorporating software engineering best practices into the data science day-to-day job. And some of these best practices include unit testing and integration testing. So these make sure our models actually work once put into production. We have load testing and output validation. So these make sure that our models are both performant and correct. And then finally, we also incorporate code review, linting, formatting, and scanning. So here we have the code that builds the models in the first place being reviewed both by human colleagues and checked by automated processes for bugs, readability, security, etc. Then at this stage in early 2022, we significantly simplified and enhanced our model deployment processes through replatforming to Kubernetes. Again, as with most of the processes we built or adopted within our pipeline, this really reduced the time to market for ideas and made our pipelines more consistent. So after building the core resources and processes within our machine learning pipeline, we worked on improvements and extensions through different tools and services. And the real aim of building these tools and services were to, firstly, to enforce consistency across all modeling operations. So this was primarily done to ensure and to keep scalability within a small team. It was also, these tools helped us to improve user experience and to unlock further insight into the models. And one of the first tools I mentioned here is an internal Python library we built to really underpin all of the previous resources and services that we talked about. And the tool itself is named Echo to symbolize the key principles that we wish to emphasize, that of reproducibility and reusability. So what is it? Really, it's just a wrapper on top of well-established Python packages. We don't want to be reinventing the wheel here, or building our own version of tried and tested algorithms. And it also contains some additional or bespoke features. So why did we do this? And why did we go off and build our own packages? Again, firstly, to enforce consistency across all our data scientists, and to share features bespoke to CarTrawler, such as certain feature engineering and pipelining of model creation and deployment, really to centralize best practices and performance optimizations in one place. One of the next key tools that we developed gave us the ability to monitor the performance of our models, and then alert us if and when they're degrading, and then automatically schedule a retraining job once a certain threshold of performance has been hit. And this whole idea of monitoring and automation is key to being able to scale our operation. As the number of models we manage grow, trying to monitor everything becomes quite difficult, if not impossible. So just a small example here, in the screenshot, we have an example of the degradation performance of a model, of a specific model over time. The blue line here represents the model error. When the service went live in May last year, it picked up that threshold for this particular model and scheduled a retraining job automatically. We then see the error being reduced to an acceptable level until it triggered a second retraining job at the end of July. And I suppose the final tool I'll touch on is our functionality that monitors the incoming data to detect changes in our modeling assumptions, and then alert the responsible data scientists to investigate. So just as careful monitoring must be placed on all the models themselves, monitoring the data that creates these models is just as, if not more important. So that really wraps up the evolution of our machine learning pipeline over the last number of years. I've outlined, over the last few slides, I've outlined the key decisions which underpin the services built. I then went on to give an overview of the services themselves and what we obtained from these services. I'll now hand it back to Mike to talk about some further business impacts.
Perfect. Thanks, Chris. So after all of that, I guess we've made it out the other side as a high-performing team with a significant role to play in the day-to-day operations and performance of the business. Linking back to the challenges we faced earlier, as Chris alluded to, we now have a scalable and flexible MVT architecture, executing multiple tests on a daily basis. These tests are not just run by the data science team, they are run by other teams around the business themselves through a UI platform that has been built as well. This really sort of democratizes testing across the business and allows everybody to get involved in testing, but in a controlled and a validated manner. Secondly, we've significantly reduced the reliance on other teams, but importantly, not at the expense of smart collaboration with other departments around the business. We have built scalable and reusable products to reduce that dependency. Thirdly, the business as a whole is more data-driven and fully supports and promotes the use of AI for automated decision-making. This was a sort of a long-term process to get the business to think this way and work this way, but we felt that like the introduction of our MVT platform allowed the business to really understand the power of testing and granular segmentations across different actions across the business. That sort of led to the formation of machine learning as a tool for automation across pricing and sorting, and really we kind of tried to build the trust and confidence in those tools over time. And lastly, as Chris mentioned again, we now have a service that allows us to deploy machine learning algorithms directly to production for the purposes of pricing, sorting, claims costs, and a whole host of other things. This is currently processing over 6 million requests on a daily basis, and we have plans to expand this even further in the near to long-term future. So I suppose all of this capability is great to have, but it's kind of useless if we're not actually getting any real tangible benefits out of it. So just to give a quick overview of some of the benefits we've seen. So our first foray into machine learning driven pricing was back sort of the end of 2019, start of 2020, was a huge success. So that was across our insurance pricing product. This delivered uplifts in the region of 7% in yield for both CarTrawler and our partners. Coming sort of hot on the heels after that, we tackled our recommended sort model, again, this time in a more sophisticated manner than we had done before. And this yielded uplifts in the region of 5%. So these were great big wins for the business in terms of proving the benefit of machine learning and proving the benefit of scoring models real time in particular. As previously stated, we now have over 15 machine learning models running in production across different areas of the business, which we feel is really impressive from a small team, especially considering they're being, as Chris mentioned, automatically monitored, maintained, and retrained when performance is degraded. Thirdly, and I was quite surprised when I looked up this stat, but we've now run over 1,500 tests through our MVT service over the past few years, which again is testament to the platform that we've built. As you'll know, not all tests succeed. That's the point of testing, but many of these have resulted in significant change to how we operate and have delivered significant uplifts in financial performance. This is a sort of a loose calculation, but we feel that like a brand new machine learning model now takes over 75% less time from inception to go live, using all our sort of current architecture and capabilities that we've built up compared to where we were, say, 4 or 5 years ago. And as Chris mentioned, our models now are really quick, real time. Therefore, they're not impacting the customer as they travel through our funnel. Our average response time is under 15 milliseconds. This still leaves us room for sort of more sophistication and improvement in our models, as 15 milliseconds is obviously an incredibly short period of time, but we want to keep that as low as possible to not impact the customer as they flow through our booking funnel. It's important to note, like, we're not resting on our laurels. We've built all this technology, but we're also continually striving to improve how we operate as a business through data science, and have a number of projects either in progress or in the pipeline. Flavor of them here. For example, we're currently developing a real-time fraud model to reduce our liability to fraudulent transactions. This will execute real-time during the booking flow using our machine learning serving platform. We also have plans to develop out a suite of automated feature engineering techniques to improve our model building process. We're also looking into automated car pricing and Bayesian forecasting for our finance team as well. And lastly, I'd like to finish on three three key learnings that we found throughout this whole process. The first one, and really this one should be obvious, is just never underestimate the power of real-time data-driven decision-making. It really has transformed the way that we do business and the way we operate as a company. One thing is, like, just don't settle for scoring your models offline. Bring them to the forefront where they can really make a difference, and sort of see that performance real time is really key. Secondly, we feel to really drive forward a data science team, they need dedicated engineering resources. As mentioned before, one of the challenges and roadblocks we hit was being heavily dependent on our P&T and engineering teams in other departments in the business. To solve for that, we brought that expertise in-house. We now have, as I said, a sub-team within the data science team that are responsible for sort of ML ops or DevOps and building out these tools and capabilities. And we've benefited enormously from that. Data scientists on their own might be able to hack together a product when needed, but really having the right people build scalable and robust products enables continuous improvements and delivery over time. Thirdly, real world machine learning models don't always work. So it's really important to sort of build trust and confidence in them, particularly to non-technically minded people. As I said before, it's useful to start small, get some quick, easy wins through testing, and then incrementally improve from there, rather than kind of going with a big bang approach that happens to fail, and then you really kind of have no comeback after that. And then just the last point, like, we believe data science needs to reliably and scalably generate verifiable improvements in profitability. And at CarTrawler, we've built a team and a culture to deliver on that. So thank you very much for your time today. And if you have any questions, please feel free to ask.
Thank you very much, Mike and Chris. That was very comprehensive, really well laid out. So we've got a few questions here. The first question I say is the priorities. So choosing which ones to work on, and then which ones to not, can be very challenging. And particularly in the world of data science, we've seen where if you work on the wrong problem effectively, it can actually be detrimental to the business because you don't get the uplift, and it can be a significant waste of time. So how did you come about forming that and choosing what to work on?
Yeah, I guess there's two things here. I think firstly, like, we do collaborate with the rest of the business on all our prioritizations. So within CarTrawler, we use an OKR process. So we define priorities on a 4-month basis across the business as a sort of top-down approach. So there's a lot of collaboration between us, the trading teams, our engineering departments, and other teams in terms of deciding what the key priorities are. But it also allows us control and flexibility over how we prioritize. So we don't always have to focus on the sort of short-term needs of the business. As you've seen, like, a lot of the tools here we've built out are sort of long-term thinking. So we're trying to develop tools and capabilities that will allow us to do things in the future. And I guess I suppose sort of secondary to that, we kind of got lucky with the pandemic. So a lot of these tools and technologies were built during COVID time, when we had the ability to sort of focus on more longer term projects as the business was, I guess, underperforming due to the lack of travel around the world. So that we benefited greatly from that, but I think it's kind of shown through now because we've seen the benefits of building out that tools. We're now seeing the growth that we're able to achieve through all the technologies we have, which has been a big win for the business, I think.
Thank you for that. So I've been making quite a few notes. It's data-driven, has transformed how we do business, and it's so impactful across the business. You talk about collaboration. Tell us about how you engage with stakeholders who aren't technical, who are usually time poor and potentially skeptical. How do you take them on that journey?
Yeah, I guess, like, we do work very closely with them. There are so a lot of the teams that we would work with tend to have different resources within those teams that are either data minded or not. And we bring sort of all of them through the journey depending on their skill sets. So the way we've done that is through some clever sort of visualization techniques and the use of sort of, we rely heavily on like Jupyter notebooks to sort of tell a story in terms of what we're trying to achieve. And I feel that that's a good way of bringing people through the process of how a machine learning algorithm works or what the capabilities will be able to provide to their particular team. Secondly to that, like we build out UI that allows us to sort of put a wrapper around the complex technologies that we develop, but make it and present it in a nice and easy to understand manner. So as I said, like with our MVT platform, like Chris showed you two configuration files there, we see them. The rest of the business don't see them. So they see a front end UI that sits on top of that, that creates that, but it's a nice and easy to use framework for the rest of the business. So I guess, yeah, that's kind of how we work.
Talk me through the build versus buy decision, because it isn't a straightforward decision. Everybody's got an opinion on that. How do you go about making those type of decisions?
Yeah, it's not an easy decision. I guess at the time we kind of felt that we had the in-house expertise to be able to build what we wanted to be able to build. We kind of were of the opinion that there are a lot of tools out there, a lot of external third-party providers that can provide you with testing capabilities or provide you with ML serving capabilities, but you're kind of paying for this whole chunk of stuff that you probably only need 5 to 10% of it. So we felt that like we were better placed to be able to build tools and services that were specific to our need, and we could build them in a flexible and scalable way to allow us to do a whole host of things. So like for example with our testing platform, we've now scaled that up to over 30 use cases, and it really allows the business to drive, as you say, data-driven decision making across a whole host of different use cases across the business. And we felt like we wouldn't have really been able to do that at the same scale or speed if we went with a third-party provider, and also just wouldn't necessarily fit as well into our current like overall back-end architecture.
What is amazing is that you've got the 7% uplift, but 75% less time to do some of these tasks. That it's such a boost for morale, I can only imagine, because in the world of data science and data engineering, so many projects just don't make it through for a variety of different reasons. And senior management buy-in, dirty data, working on the wrong problem, a variety of different things. This would give everyone a lot more confidence with the type of bold projects that you're looking to do in the future.
Yeah, absolutely. And as you say, like it creates a huge amount of engagement and a great morale across the team. Like people are working on projects that are really impacting the business, and we're getting there in a quick and timely fashion, as you say, with a reduction in time to market. And like that has been underpinned by the capabilities and tools that we've built. Like in particular, the one Chris mentioned, our Echo product, which means that we have sort of transferable. What I mean is it's built. Our models are built in such a way now that we can transfer people across from model to model because the code is all standard, it's all understandable, and it really sort of improves that engagement across the team. So people are able to work on a pricing project during one sort of OKR priority period, and then the next one move on and work on a sorting project and try their hand at improving that model. And that really sort of not only improves the skill sets of the people in the team, but I feel like really improves the engagement. People are really bought into the models that we build, and they're really bought into the fact that we actually get to see those models live in production, and really see the results and really be proud of the sort of impact that we're able to have on the business.
everybody comes to work to make an impact. So it's great to see this story and hear it and provide such great examples throughout the way. Mike Wilson, Head of Data Science at CarTrawler, and Chris Laffey, Senior Data Scientist at CarTrawler. Thank you very much for your time today.
Thanks, Mark.
Thanks, Mark.